So for question number 2 on complex numbers, we have to introduce this thing called de Moivre's theorem, which allows you to find the square root of a complex number, which is what's required in this question. Here is de Moivre's theorem underneath, which is on the equation sheet, so you don't need to remember it. All it's telling me is if I'm finding some complex number and it needs to be in polar form to work, to a raised to the power n, for example, so squaring or cubed, then what do? I just take the number and square that or cube it, or so on, and then multiply the angle by that number. For example, square 5 angle 15 degrees. I'm going to square the 5 to get 25, and I'm going to multiply the angle by 2, 15 to 30. Simple as that. What about a square root? Well, if you're thinking about square root, remember this means the square root is a 2 outside the bracket, and it's though this is all raised to the power 1, so square root would be 5 angle 15 to the power a half, using the laws of indices. So now I just find the square root of 5, which is 2.24, and half the angle, 15 divided by 2 is 7.5. So that's how we use de Moivre's theorem, and that's exactly what we've got to do here. I've put the numbers in and worked it through. See if you can do it for yourself. So the first step, if you look at the numbers, R and omega and L have been put in, G and omega and C have been put in. Quite awkward numbers, but it's just a case of putting the numbers in. Remember, these numbers now have to be converted to polar form, so you can then multiply them together in polar form, which is just multiply the numbers and add the angles. Then you can use de Moivre's theorem. Have a go and see if you can work it out. The solution follows. So if you look at it, converting this to polar form, actually you can put this number in pretty well as it is on here. I put 25 in, so I hit shift polar and then 25 and then comma, and then put in 20 pi times 15 times 10 to the minus 3. It will accept that, and then it gives me this value. Next one, I put in 12 shift polar and then 12 times 10 to the minus 6, comma, and then 20 pi times 12 times 10 to the minus 9, and it will give us this. See where you don't miss the times 10 to the minus 5 in the answer there on the calculator. So multiply them together, multiply the numbers to get this, add the angles to get 5.8, and then remember the square root is to the power half, so square root 3 times 10 to the minus 4, and half 5.8 to get that as my gamma, which in fact represents the transmission coefficient constant, isn't it? Something like that. Propagation coefficient. Okay, and it can be a similar sort of question in the exam. The numbers make it awkward, but the process is actually, with practice, quite straightforward.